Mike, or winds in excess of 60 miles an hour, but how we get them in some storms is a pretty intense situation.
It is, and we think there's a possibility we can see downbursts tonight in some of the storms that we have across Texas. Dr. Navarro with us here for a little explanation with some chalk talk here, because people probably hear this word and they're like, okay, I get that. It's maybe something that comes with rain, but it may come without rain even.
That's right. Sometimes you hear the word microburst, wet microburst, dry microburst. You know, those are all related to the same thing. It has to do with the thunderstorm cloud here and how that interacts with the environment it's surrounded in. So in our typical thunderstorm cloud, we'll have a very warm layer and an inflow here that gets sucked into the storm and then rises into the storm. It's in here that we get all the water droplets, and then as we get up higher in the atmosphere, we form hail and those frozen particles, right? But when you've got this presence of dry air in the mid-levels, notice this is lifted a little bit up. A lot of this dry air can get wrapped into the thunderstorm here by the circulation of the storm as well as turbulence. Some of that dry air can make its way into the center part of this system, and then all this moisture sees that dry air as an opportunity to evaporate, essentially. And so all of those particles start to evaporate into the air, and that has a profound cooling effect inside this storm. That cold air, we've talked about this many times, is heavy, it's dense, and it's less dense than its surroundings. So that wants to sink and start falling out of the cloud. And then we get very strong winds down at the surface. But Mike, there's a really important factor tonight in places of Texas that's a key.
What's so interesting about Texas tonight that's going to make this significant?
Yes, so we also have down here the presence of a very warm boundary layer. The temperatures here are in the 90s, so that's pretty hot. So when you have all this cold air that's descending out of the cloud encountering this very warm air, that contrast is even bigger than typically we would expect. And so that means that we have the great potential here for some very strong downbursts that hit the surface and then spread out. And that's where we see the damaging winds on the leading edge of this expanding wind flow, and this could be on par with some weak tornadoes. And
you mentioned something like a wet microburst or a dry microburst. What will we have in this situation in Texas tonight?
Yeah, we could be looking at some wet microbursts for sure. We've got a lot of moisture included in these, so it really just depends on the environment within the cloud and how things play out.
When we take a look at, and then when there's a different scale, small versus large in essence too.
Yes, so if you ever hear these words turned around, the difference between a microburst and a macroburst is really the size and the duration of that type of event. A microburst typically happens in an area that's less than 2.5 miles, so pretty confined, and it's also short-lived, less than 5 minutes. But you can have some very large-scale wind events here where they're greater than 2.5 miles wide, which is a lot. So that's pretty big, and they could last for anywhere from 5 to 20 minutes.
And if you have to sustain an event like, if you're in a neighborhood that is going through something like that, you're getting a really big thunderstorm overhead that's putting out a lot of air.
Yes, and it's, again, this could be on par with an EF1 or an EF0 tornado, so that is enough to cause some issues.
Not out of the question for a downburst to produce 100-mile-an-hour winds.
No, not at all.
All right.